All right. Welcome to 4.4, day 1. This is going to be split into 3 days. We're factoring by GCF, which stands for greatest common factor. And so our essential question, how do you factor a monomial from a polynomial? Monomial, this means one. Okay, so one part. Poly means many. And so from many parts. Yes, we're going to take one part out, basically. All right, so the distributive property here, the freshmen call it rainbow magic. Okay, we multiply each piece, right? So 3 times x is 3x. 3 plus 5 is 15. Okay, now what happens here? I realize I got writing here. There we go. What happens here when we multiply 5x times x? X times x is x squared. So we end up with 5x squared and then minus 40x. Okay, lastly, I guess not lastly, but 12x squared times x is going to be 12x cubed. It goes up by a power when you multiply. And then here we have 36x squared. Okay, lastly here, let's distribute this through. 5n times 3n cubed would be 15. So we multiply the numbers. 5 times 3 is 15. N times n cubed would be, remember it goes up a power when you multiply, so n to the 4th. Okay, now 5 times negative 1 would be negative 5, and then we have n times n squared would be n to the 3rd, and then lastly 8 times 5 is 40, and 40n. Alright, on this one, now when we factor a polynomial, that just means we're writing the expression as a product of its factors. And so to start out with, instead of writing 21, we could write the numbers that multiply to 21. We could write 3 times 7. All right, now when we find the greatest common factor, that means that we're going to divide, or we're going to find the number that, the biggest number that can be divided evenly into both numbers. Okay, and so we think about what can we take out a number from both of these evenly. 5 doesn't work. 3 would work, but I think we can find something even better. I know that this is divisible by 9 and this is also divisible by 9. And so let's take out a 9. I can't take out a b because this one doesn't have a b. Okay, so all I can do is take out a 9 from the numbers. So 45 divided by 9 gets us 5. I can't do anything with my b's. And then 27 divided by 9 is 3. Okay, so the greatest common factor here would be 9. That's what I was able to take out. Okay, now when we find the greatest common factor here, let's first look at the numbers. What's the biggest number I can take out of all 3 of these? It has to be all 3. Well, the biggest number I can take out is a 2. Right, so if I take out a 2 from all of these, then I'll be able to reduce this down quite a bit. Okay, now let's look at the x's. Can I take an x out from each piece? And the answer is yes, because they all have an x. Okay, so I could also take an x. And then what I'm going to be left with is, so 4 divided by 2 is 2. X cubed divided by x is x squared. Oops. Kind of going in reverse of what we just did. Okay, now the next term, 2 divided by 2 is 1. X squared divided by x is just x, so it's 1x. And then here, negative 8 divided by 2 is negative 4. X divided by x, it cancels itself out, and so we're left here. So our greatest common factor of these 3 terms is x squared. Or sorry, 2x, not x squared, 2x. All right. So now here we're going to find the greatest common factor, and then we'll actually factor. So we'll basically kind of just be doing what we were. So first step, let's look at the numbers. Okay, what do they have in common? What can we divide both numbers by that will work out? We can take a 2 out of both of them, can't we? Okay, so find what they all have in common. They have a 2 in common. Also, they both have x's, don't they? So we can also take out an x, and then what are we left with? So we pull out the GCF, our 2x, and then we write the leftovers. So 6 divided by 2 is 3. X squared divided by x is just x. Okay, and then 2x divided by 2x will just get us 1 left over. Okay, you can always check this. You can always redistribute and see if you get the same thing. So here we'd have 6x squared plus 2x, and that's exactly what we had up here. And so we know we did it right. All right, here's another one. Think about what can we take out for the numbers. Well, we can take out a 4 goes into both of them nicely, and then they both have an x, so we take out an x. That's our GCF. It's our greatest common factor. So the biggest thing we can take out of both things. All right. So then when we factor it, we write our greatest common factor and then whatever's left over. So 4 divided by 4 is 1. X squared divided by x is just x. And then negative 28 divided by 4 is negative 7. X divided by x is, they cancel themselves out. And so we're left with, this is our factored expression. Okay, over here, biggest thing we can take out from both of these things is a 3. And they both have an n, so we can take out an n as well. And so this is our GCF. Okay, 6 divided by 3 is 2. N squared divided by n is n. 9 divided by 3 is 3. N divided by n cancels itself out. Sorry, that's a 2. All right, last thing here. Now we're going to ramp it up just a little bit. We're going to have 3 terms here. Ask ourselves, what can we take out of all 3 pieces? For numbers, I think this is divisible by 3, that's divisible by 3, and that's divisible by 3, right? Oh, I'm not quite ready yet to factor. Okay, now what can I take out for x's? Basically, you're going to go with the lowest amount of x's. And I can take out 3 x's because these two have more than 3 x's to spare. So if I take out an x cubed, I shouldn't say 3 x's, an x cubed. If you take out x cubed, then 9 divided by 3 is 3. X to the 6th divided by x to the 3rd gets us x to the 3rd. Okay, just think of it as we have 6 x's here, and then we're dividing by 3 x's. Okay, we cancel this one out, cancel this one out, cancel this one out. How many are we left with? We're left with 3 of them on top. So that's kind of how we're working these things. Okay, 15 divided by 3 is 5. X to the 4th divided by x cubed will get us just x. There's just 1 left over. And then 12 divided by 3 is 4. X cubed divided by x cubed is cancels itself out. So here is our completely factored thing. Now, if you get to this point and you realize that all of these numbers can be divisible by yet another number, so let's say they were all even and we could divide them all by 2, then we know that we did not take out the biggest number we could have taken out. It's time to go back and look and see which number is bigger that can be taken out evenly. Okay, so this one, for example, if I took out a 2 from each of these, I would still be left. Let's just kind of play a scenario here. If I took out a 2, and then all of these, I can take out an x from everything. Okay, I'd be left with 4 divided by 2 is 2, and then x cubed. 12 divided by 2 is 6, and then we have x squared. And then 8 divided by 2 is 4, and x divided by x cancels out. Okay, now at this point, like I said, I'm doing this wrong on purpose because I realize what I have left are all even numbers, aren't they? I can take out another 2. And so I need to go back to the drawing board and reevaluate. I must not have taken out the greatest common factor. And as you probably saw right away, the greatest common factor, all of these can be actually divided by 4. Right? And so I'm going to take out a 4, and then x is still the biggest variable I can take out. 4 divided by 4 is 1. X to the 4th divided by x is x cubed. 12 divided by 4 is 3, and then we have x squared. 8 divided by 4 is 2, and the x's cancel out. Now here, we can't take anything else out, right? So I know that I did it right. And if you always want to check, you just redistribute and see what you get. All right, there's your homework, and that's 4.4 day 1.